Hello class, and welcome to lesson 2.5b, finding equations of a sinusoidal curve. Again, this is a two-part series. We discussed this last class. We're just going to extend it a little bit further today. So let's just quickly recap what we should know. For example, how do we find the period? That equals 360 degrees divided by the absolute value of k. We also learned that if we swap, ladies and gentlemen, the k and the period, or switch them around or resolve for them, that k equals 360 divided by the period that you can see in your graph. Okay? We learned that the minimum, ladies and gentlemen, is your C value, subtract the absolute value of A. So your axis, and then you subtract your amplitude. Your max is going to be C plus your amplitude, or your axis amount plus your amplitude. And the amplitude, ladies and gentlemen, does equal the absolute value of A. And if it equals 1, it's normal. Your axis of the axis equation is Y equals C. Your starting point is D, and your range, ladies and gentlemen, is the longer one. Remember, Y belongs to a set of real numbers such that you take your minimum and your maximum. All right. Okay. Let's take a look at some examples. So number 1, write two equations for each function, one as a cosine curve and one as a sine curve. Most of the important pieces of information stay the same regardless of what your parent function is, i.e. the period, the amplitude, and the axis. They stay the same. The only thing that differs when you're taking a look at what's your parent function using is the starting point. So let's look at this graph, ladies and gentlemen. First of all, the easiest thing I like to point out is our equation of axis. Okay, so our equation of axis here, folks, is C equals 1 because it's Y equals 1 for the equation. All right, next I want to find my amplitude. So my amplitude is 2. So if my amplitude equals 2, therefore A equals 2. Okay, trying to take a look at my period. Now, depending on where you start. So let's pretend we're starting with cosine first. Okay, if I draw my box around cosine, okay, my cosine this time has a period of 10. Look at your scale, folks. It changes depending on what we're looking at. Okay, so for cosine, I have a period of 10. Okay. All right. And starting point for that would be at D equals 0. Now, if I try to do the sine x and I box it out, okay, it depends on where you want to start. Let's start right here, guys, because this looks nice. Let's start here. So to do a complete one here, okay, looking at that, ladies and gentlemen, it looks like it's negative 2.5 for our D value. All right. Any questions there, ladies and gentlemen? Okay, we haven't figured out our, sorry, my fault here. That is our period is 10. So we have to figure out our K value. So K equals 360 degrees divided by your period, which is 10 degrees, and that is 36 degrees. And it's the same for both your cosine and your sine curves. So subbing in the information we know, we can now do our let's do our cosine first. So y equals a, which is 2. Cos of what's our k value? It's 36. And x minus d, so it's just going to be x plus c, which is 1. Now when we want to do the sine curve, we've got to be careful because it starts at a different d value. Okay, so y equals 2 sine, okay, have your k out front this time because it has to be factored. It's going to be x plus 2.5 plus 1. All right. There's our first example of showing you how you can take a graph and depending on your box, you can come up with a cosine or a sine curve. And that is true for all of these waves because remember the definition of a sinusoidal can be a transformation from either the cos x parent function or the sine x parent function. Let's try a second one here, guys. Okay. Taking a look at the second one. The period. Okay, well, let's go in order of what's the easiest one to do first. So the easiest one to do first is try to find our axis out. Okay, so our axis is here. Okay, so our axis, ladies and gentlemen, is y equals 2. Therefore, we know c equals 2. From that, let's look at our amplitude. So from that, we should take a look at how many times how long does it take to get to its minimum or its maximum. You should have amplitude equaling 4. Therefore, a equals 2. All right. Now, what's the time it takes to get from a maximum to a maximum? Okay, your period is looking like it's 180. So period equals 180. So to find k, that equals 360 degrees divided by your period of 180 degrees. So k equals 2. All right, so far those three stay consistent. Then we got to look at our starting point. So let's start with our cosine. Okay, so we're going to start here. I'm just going to box it out for you guys so it's easier to see. If I'm looking at my cosine curve, what's my starting value? It's actually at 0. So d equals 0 for that. Okay. However, if I want to do my sine curve, you got to be careful with this one. With the graph given, I don't have, for example, it looks like it starts right here, right, guys, and then does the curve. However, I don't have a complete graph for that. So what I'm going to do is I'm going to flip it and start it here and make it a negative value, okay? All right, so we're going to make a, in this case, negative, and we're going to start that d value at, my fault. We're going to start that d value at 45 degrees. So d equals 45 degrees. And for this one, we're going to say that a equals -4, and that's for the sine. Okay? Just so that it fits it on the graph. Because, ladies and gentlemen, if I go to box this in, I now have a box but it just is what we call the reciprocal. It's been flipped or reflected by the axis of symmetry. All right, so let's write our equations in. Let's start with the easier one, which is cosine. So y equals my amplitude, which is 4, because it starts at its maximum, right? Cos of, what's my k value, ladies and gentlemen? So my k value is 2. Okay, and x plus 0. So you could have the big brackets or the smaller brackets. That's okay. Plus 2. Okay, now to do my sine, it's y equals -4 sine of, again, we've got a d value, so we've got to factor that part out. So it's going to be x minus 45 degrees plus 2. Okay. Any questions there, folks? Can I show you another example here if you don't like the negative a? Okay. The other thing you could do is say, hey, Where does this initially start so that I can be positive? I.e., whereabouts over on this side of the graph would it start? So if you take 45 and you subtract 180, you could have a starting point, ladies and gentlemen, um, at negative 200 and whatever, or you could start here, which might be the easier part, is to start here and have your base here and where it's going to be opening and closing. So if you wanted to do this value, you could then make the amplitude be positive. So you could say y equals 4 sine of 2x minus 135 plus 2. Again, those are equal just because there's 180 degrees difference between negative 45 and negative 45 with it flipped, which means it would really be at 45, and negative 135. Okay? All right, let's move on. So this is a question from your textbook, ladies and gentlemen, just to give you a little understanding of what's going on here. It says, represent the graph of 4 sine times 3x minus 30 with the equation using the cosine function. So in this case, folks, it gives you the sine transformation. They want you to convert it to a cosine. What we learned in the last example, what can we use, or what information's the same? So what can we use? So first of all, A should stay the same because it tells us our amplitude. So we know A equals 4, which is our amplitude. What else do we know, folks? That K equals 3. So if you want to find out what your period is, that's 360 degrees divided by 3. So my period equals 120 degrees. Okay. I also know that C equals 0. That tells us that Y equals 0 for our axis. So I'm going to draw that right away to help us. Okay. And what we need to know here is with the sine curve that it's D, our starting point equals 30 degrees. Okay. So instead of starting at 0 for my sine curve, I'm starting at 30. So if I just take a look between 90, I've split it into 3 points. It's going to be here. And then if I take 30 degrees and I add 120 to it, that's going to give me 150 degrees, and that's right about here. So in that time, ladies and gentlemen, I have to do um, one complete cycle. Okay, so basically I'm going to go up because it starts to go up, and I'm going to go up by 4, and I'm going to come down by 4, and I'm going to draw that. Okay, I'm going to do that cyclic a little bit more. Okay, so if I take what did I say, 150, add another 20 to it, and add another 120 to that, which should be 27. Nope, say that again. So let me do that math again. So 120 plus, where did I end off again? At 150. Ah, that's 270. Good. Okay. So at 270, I've got to have my other one, and except I've got to shift it over 30 degrees. So it's going to be 30 here and shift it over 30 degrees here. Okay. And this continues on throughout the rest. So you could just draw an arrow there because we only need to make sure we have one, that we have at least one spot here to make our cosine. Okay. So what we need to do, folks, is to take a look, and I apologize, guys. These should have come right up to 4. So let me just fix these, please. Okay. I just got a little lazy, sorry. There we go. All right, so what we need to do now is, now that we've got our sine transformation drawn, now we're going to graph out or map out where we are going to start our cosine. So I would start our cosine right about here, okay, and we'll block it off right there, okay. All right, so looking at that point, guys, where do we start? So D is going to be the change here, and D is going to start at about 60 degrees. Okay, so that's the other key of the information that changes when we do this. Okay, so we can now write this out. Y equals our amplitude, which is 4, times the cosine of what our K value is 3. Notice there's 3 different reps within the 360 degrees, right? X minus 60 degrees, that was our starting point, and plus 0. All right. And just make sure, ladies and gentlemen, that you look for it goes to its max first, okay? Otherwise, it could have been flipped, and you could have done a negative A if it was, but it looks like it's at its max, okay? All right, so that's how we picked our starting point. We looked for the first maximum. All right. Hopefully you understand that. We're going to do one final example before I let you do your work. It's a different type where we're not given a graph and we're not given the transformation information. We're giving a set of data points. And I will tell you coming up after your quiz, we will be taking a look at applications where we're going to be modeling some of this data in a little bit more detail. All right. So taking a look here, find an equation to model the data below. So what we need to do is look at our data, and first of all, we need to find out the period. So the period is the length of the time it takes to get from a maximum to a maximum. So let's take a look at our y values. So to get from 3 to 3 here, how long did it take? Okay, so to get from 3 to 3, how long did it take? It took us 120. So we'll say period is 120 degrees. And from that, ladies and gentlemen, we can find K. So K equals 360 degrees divided by the period, which is 120. So K equals 3. All right, trying to figure out our amplitude. Our amplitude is taking a look. What's the change as we go, or our first differences? So it's going to be taking a look here. 2 subtract 3 is -1, and then -1, and then 1, and then 1, and then -1. So what do we notice? We've got the max to the origin, to the min, to the max. Or sorry, let me say that again. You go from your maximum to your axis to your minimum to your axis to your maximum. So what the amplitude is, the absolute value of 1 and -1 tells us that amplitude equals 1, therefore our A equals 1. Okay, to figure out our axis, that's a little more difficult. Okay, just think about drawing this. If we're at 3, and then we go down to 2, then we go to 1, and then we go to 2, to 3, to 2, to 1, you know, you've got a little curvy here like this. Where is the axis, ladies and gentlemen? It's at the values that are in between. So your axis is y equals 2. So therefore, C equals 2. Now the starting point is one of the probably hardest things to take a look at. So let's just take a look at where the graph started at 0 and 3. Okay, so it doesn't start at 0, 0. So what that means is it starts on the y-axis, and this is our max, right? So it starts at our max. So therefore, that tells us we're going to use cosine, because we're not starting at 0, 0. We're starting at 0 and 3. Okay, so we're not starting at the origin. What does that tell us? That we're starting right at our maximum. That means there's no shift in our start value, which means D equals 0. Putting it all together now into our equation, y equals cos times 3x plus 2. All right, so there are some examples to show you the opposite way to come up with the equation. And again, you could have done transformations to get a cosine or get a sine there as well, because any sinusoidal function can be a transformation from either the cosine x function or the sine x function. Here's your homework for today. It's page 36 to 38, numbers 2, 4, 7, 10, and 18. Okay, I also reposted here the extra hints as a repeat from last lesson, just in case you missed it, ladies and gentlemen. Okay, And again, if you need any extra help, come and see me. And I'll just post the homework back up again so you can see it. Have a great day, guys.